Partial fractions, part 3. Example 3. So we have a fully factorized denominator. So that would be the first step. If this was not factorized, that's what you do first. Fully factorize your denominator. And then using these factors, x, x plus 1, x minus 2, we write down our partial fractions. So we have 3 of them this time. The letters A, B and C are just generic. You could put other letters here, or you can move the order around of the A, B and C. It's not going to change anything. Here's the long version. Just like we did in example 2, we multiply these denominators together to get the same denominator as the other side. That's what the aim is. We want the same denominators on both sides. So starting with the first fraction, so what do I multiply the A with? Now in the denominator we have x, so it's going to be x plus 1, x minus 2. It's everything else other than the x, so x plus 1, x minus 2 plus, and then for b we've got x plus 1 here, so we're going to multiply with x and x minus 2. And then for c we've got x minus 2 here, so we multiply by these two, the x and the x plus 1. So now we have the same denominator on each side, which means this numerator must be equal to this numerator, because we have an equation with one fraction on each side. If the numerators are the same, the denominators are also the same. Now a shorter method instead of this, where you can write down this all in one go, is the following. Start by looking at the numerator on the left hand side. Let's write that down. 5x minus 8 equals, and then we have a, and the denominator is x, so we're going to multiply by x plus 1, x minus 2. And then we have plus b, and this time the denominator is x plus 1, so we multiply by x, x minus 2. And then the final one, plus c, and the denominator is x minus 2, so we multiply by x, x plus 1. And it's quicker to do this than to do this. So if we substitute in x equals 0, then this becomes 0, x is 0 times the rest becomes 0. We can solve to work out a is equal to 4. If we substitute in x equals minus 1, so put minus 1 here, that becomes 0. Put minus 1 here, this factor here becomes 0. We can work out b. So b is equal to minus 13 over 3. And to work out c, well, we already know what a and b are. An alternative method at this point could be try any value of x that you like, and the only unknown in that case would be c, and then you can work out what c is. But I'll stick to the method that we've used before. To eliminate a and b, we need to get rid of the x minus 2 and x minus 2 from here. If we can make the x minus 2 is equal to 0, then it will eliminate those two terms. So substitute in x equals 2, that factor is 0 times the rest is 0. Substitute in x equals 2 here, that factor is 0 times the rest is 0, and we get c is equal to 1/3. So a equals 4. b is minus 13 over 3, so minus 13 over 3. We need some brackets here. Or you can multiply the brackets out and write 3x plus 3 in the denominator, but I'm going to leave it like this. And the final one, c, is equal to 1/3. So we have 1/3, and again we need some brackets here. To check my solution, I've used x equals 4, just some dummy value of x. I can't use 0 or -1 or 2 for x here, otherwise you end up dividing by 0, which will give you a math error. Now I need to substitute that value of 4 into all of this, into this fraction. So for the left hand side, when x equals 4, you get 3/10, and you can see the working out here for the calculator. And for the right hand side, again, when x equals 4, you get the exact same value, which means the values that I've calculated are correct.